Our team is called StAyaL, and our goal is to translate your personal style in multiple different languages. So how do we go about defining style? Next slide, please. So after multiple thought experiments, we define style as your personality conveyed through language, oftentimes in multiple different scenarios. And our goal was to take down the language barrier so you could be your true self across different scenarios, languages, cultures, etc. So why not just use a traditional translator for this? Next slide, please. So lots of times these translators will take away your emphasis, they'll take away kind of your adjectives, your own personal way of speaking. They can even make you sound insulting. One example, I was trying to tell my significant other that her dress was stunning. The translator said shocking or glaring. Clearly not what I was trying to say. So how do we address this scientifically? Next slide, please. So two women much smarter than me who really drove this process are going to go in depth, but from a high level standpoint, we wanted to take a small amount of text. We didn't want our speakers to have to write a novel to train a model. We didn't want you to have to self-stereotype in a prompt. We just wanted to take a small amount of text, combine it with the power of Cohere's tools, generate a style profile. And from there, I'm going to pass it along to Katrina. Next slide, please.
Thanks, Kyle. So data scientists and machine learning engineers spend on average 60% of their time cleaning and pre-processing data. This project was no exception. Next, please. We went through a rigorous and iterative process to prepare our data. We started off by collecting data from Aya in 6 different languages. We then extracted speaker quotes within the Aya dataset. We collected 100 lines of translated speaker data per language and combined the Aya data with our speaker data. Next, please. This resulted in 15 unique data sets of approximately 50,000 rows each. We have data in English, German, French, Spanish, Tamil, and Cantonese. Next, please. The embeddings are where the magic really started to happen for us. We were able to capture that intangible aspect of style and make it tangible and make it real. We settled on Cohere's Embed v3 model, which is language agnostic. We inputted our sentence chunks into the context window, and our model output a list of floats. Next, please. Once the embeddings were generated, we created topic clusters so that we could find true style without the noise of semantics. We use agglomerative clustering, which is unbridled, such that the number of clusters was not predetermined. I will pass it to Karishma for our data modeling. Next, please.
Beginning with the data augmentation, we computed the cosine similarity between the speaker's text embeddings and Aya's and kept those with the highest scores. In total, we were able to boost our data set from 100 records per speaker to over 10,000 in total. Next, please. Here's an example of the augmented results. Katrina, could you share your thoughts?
We were blown away by our results. The speakers thought the augmented data sets were actually their own. It picked up on their dialect, their slang, core values, and even figures of speech. Next, please.
We in fact computed the average cosine similarity among the speaker embeddings per cluster. And while this was lower than expected, during human evaluation, our 5 multilingual subject matter experts thought the noise was in fact very good in capturing text in varied contexts, which would improve the predictive capacity of our final model. Next, please. And so now I'll go into how we trained a contrastive learning model to detect style using our augmented data. We pass our data in as pairs, indicating same or different speaker and content for all languages. We then leveraged a Siamese network of 2 identical sister networks with dynamic weight sharing to map the data pairs while employing contrastive loss. Next, please. And here are our results. If you look to the diagram to the right, we see how in the latent space, our model is able to successfully separate similar and dissimilar pairs. So whether 2 texts belong to the same speaker. The trained model results are also compelling, with a test loss as low as 0.16. For next steps, there are so many avenues we'd like to explore. We're interested in using the learned model representation and generating stylistically consistent speaker text. Next, please.
So in conclusion, we took the science and math and really extracted the poetry and personality from our speakers. And communication is really what connects us all, obviously, and your personal style truly matters. So this is just the beginning of our project. We have quite a few use cases and quite a few different stretch goals that we'll be working on. On the next slide, you'll see our personal information. Please don't hesitate to reach out. Thank you all so very much for your time.